Well, good morning, chemistry students. Hey, it's May 26th. Holy cow. Year's almost done. All right, today we're going to try to learn how to do percent composition calculations. So I want you to be able to calculate percent composition of a chemical formula. All right, so let's just review. Oh, by the way, when we're doing our composition calculations, we're going to be working by mass. There are other possibilities, like by volume. We'll be doing by mass. So let's just remind ourselves of how to do a percent calculation. So let's imagine you were doing something where you say, what percent of the people in the room are female? Think about, what do you need to know? Looking for options? Yeah, Jasmine? Yeah, you're right. I need to know how many females there are. So let's say I look around. Looks like 7 females. What else do I need to know? Connor, what do you got? Yeah, you're right. I need to know how many total people there are. So let's say in our room we have 11 people. All right. So then as a percent, we know that 7 of the 11 are female. And a percent means, what does that equal out of 100? So in other words, it's a proportion. We say that would be what out of 100? Percent means per 100. And mathematically, that just means you take whatever our ratio was times 100. So 7 of 11 7 divided by 11 would be 0.636363 repeating, times 100 would be 63. Well, I guess if I didn't give very good sig figs. Actually, I can probably count 7 exact, and I can probably count 11 exact. So I really could keep probably a lot of sig figs for this. So I'll just go 0.6364% female. Okay? All right. And you know, you've done percents in lots of classes, math classes, etc. And it's a pretty basic concept. So now what we're looking at is, how do we apply this to a chemical formula? So what percent of the mass of water is composed of hydrogen? Now I have this problem already written out. It's going to save a little bit of time on the video, but please listen to what it would be step by step. Look at, what is this? That should look familiar to you, okay? And that is me writing out a formula mass calculation of water. So I said water has 2 hydrogen and 1 oxygen, and here's the mass of hydrogen when I look it up on the periodic table, and here's the mass of oxygen. And so the 2 hydrogen have a mass of 2.016, and the 1 oxygen is 16.00. And when I add them together, I got to round to the nearest hundredth, 18.02 units. Okay? That's the mass of a water molecule. But when I write this all out, I have all the information I need to do any percents. So in this question, I was asking what percent of it is hydrogen? Well, we look right here. Of this 18.02 units, 2.016 units were hydrogen. So what do? I take the mass of the item I'm looking for, hydrogen, divided by the total mass, times 100, and I find out that water is 11.19% hydrogen. How would I find out the composition of oxygen in that? Well, I could just set up a ratio and say 16.00 grams or units of the 18.02 units times 100 is going to be, and I could calculate that out, Or, since I know this only has two elements, I could take 100 minus this and come up with 88.81% oxygen. So I have really, for the second element, or the last element, I have two ways. I could set up another proportion, but honestly, once you have this written down, finding your masses is really simple. Or your percents is really simple. So, all right, let's do the percent composition of aluminum oxide. Now, if that were your original problem, you'd have to first figure out what is the formula of aluminum oxide. And you say, well, aluminum is plus 3 ions, and oxide is minus 2 ions. And in order to get a combination where the positive and negatives balance each other out, you need 2 aluminums for every 3 oxygens. If you have to go back to your formulas and naming worksheets, go for it. But I figured out that it's Al2O3. So, what's this part? Formula mass. I've got 2 aluminum times the mass of aluminum. I got 3 oxygen times the mass of the oxygen. Here's my subtotals. And here's my total. Okay? So, 53.96 units of the 101.96 units are aluminum. So when I set that up and multiply by 100, I come up with 52.92% aluminum. And for the oxygen, I just took, well, 48 units of the 101.96 units. Make that ratio times 100, 47.08% oxygen. So, percent composition of aluminum oxide, if it just is worded like that, means you got to find all the elements. All right, this one, what I want to do is I want to find what percent of copper sulfate pentahydrate is water. What percent of copper sulfate pentahydrate is water? So you got this compound, part of it's water. How much? So I abbreviated this a little bit here, just to see very clear. There's 1 copper, there's 1 sulfur, there's 4 oxygen, 10 hydrogen, and 5 oxygen. Why didn't I put those oxygen all together? Because I'm looking for the water, and I know that some of these oxygen are in the water and some of them are in the other formula. It's better to separate. I didn't write down my individual masses this time because I was just working fast, okay? So this is the mass of 1 copper. This is the mass of 1 sulfur. This is the mass of all 4 oxygen. So I already did that math. This is the mass of 10 hydrogen, because there's 5 water molecules, which should have, 2 hydrogen and 1 oxygen in each. So that's 10 hydrogen and 5 oxygen. Here's the mass of another 5 oxygen. So when I went this way, my total mass of everything in that formula is 249.70. But then I did a little bracket here. I said, well, this is the part, this much of it is my water. So 90.08 units are due to water of the total mass, right? Same concept applies. On top, I'm putting what is the mass of the part I'm looking for. On the bottom is the total mass, times 100. When I get out a sample of copper sulfate pentahydrate, 36.08% of that sample is water. It's got water incorporated into the crystals. So feel free to take as much time as you need to look over those samples. I'm going to give you a couple problems to do to turn in. Let me know if you have questions.